All right, I've got a few questions from the forum to go ahead and do, so I'm going to go over doing them. Uh, to repeat, because I've gotten a few questions about this, uh, the WebWork questions all use some sort of randomization, so your question might look a bit different than mine, and thus your answer might be a bit different than mine. So plan accordingly when you're doing it. Yours should be very similar to mine, so you should be able to follow along with what I'm doing, but your answer won't be exactly the same. Okay, so I think there are three questions I'm going to do. So let's do derivative review 4, question 2, which asks you to find the tangent line to y equals 4 times x minus 1 over x cubed at x equals 2. Okay, so let's go ahead and do this question. So first of all, I'm going to need my y prime. In order to find y prime, I'm going to need to use the chain rule, because this is definitely a composition of two functions. Oh, I am realizing that this has gotten out of focus. Let's see, did that make it better? That looks much better. Okay. So we want to write down here sort of what is our outside function, what is our inside function, and work from there. So our outside function here is going to be 4x cubed, and our inside function is x minus 1 over x. Okay, again, I want it to be the case that if I plug g into f, I get the thing I'm looking for. In this instance, my little f prime of x is 12x squared. And my little g prime of x is going to be 1. And then the derivative of 1 over x, remember that's the same thing as the derivative of x to the minus 1. So that's minus 1 over x squared. So this is a minus 1 over x squared, so it ends up being plus 1 over x squared there in g prime. So then y prime, by the chain rule, is going to be equal to f prime of g, so that is 12 times x minus 1 over x squared, times g prime. And g prime is going to be 1 plus 1 over x squared. Okay. So that is my derivative courtesy of the chain rule. Now, what I'm trying to do here is I am trying to find, in fact, the tangent line at x equals 2. So let's first go ahead and find the slope. So the slope there, I'm going to get that as y prime of 2. And so that's going to be 12 times 2 minus 1/2 squared times 1 plus 1/4, which is going to be 12 times 9 over 4 times 5 over 4. Okay, which is, let's see, that's going to be just 3 after I cross that out. So 3 times 9 is 27, times 5 is 135, so this is going to be 135 over 4. 27, yeah, okay. I agree with myself, which is good. Okay, we'll slide this over here. Go ahead and continue on the next page. So that's our slope. We didn't actually find the point since we were only given the x-coordinate, so let's go ahead and figure out the point. So we know the x-coordinate is 2, and we know the y-coordinate here is going to come from f of 2, or y of 2 in this case. So y of 2 is what I get if I put 2 into the original function, which is going to be 4 times 2 minus 1/2 cubed, which is going to be 4 times 27/8, which is going to be 27 over 4, if I did that right. 4 times 3, 27. Okay. And so, sorry, 27 over 2. Apologies. When I multiply 27 over 8 by 4, I get 27 over 2. Okay, and so this is 27 over 2. Okay, so then writing down our y equals mx plus b formula for the tangent line, I'm going to get y equals 135 over 4 times 2 plus b. Sorry. That is my general equation, y equals mx plus b. And then I want to plug in, I got ahead of myself there, I want to plug in the coordinates and the point. So that will give me 27 over 2 equals 135 over 4 times 2 plus b. So b is 27 over 2 minus 135 over 2, which is going to be, if I calculate this out, negative 108. If I added those, yep. Negative 108 over 2, which, as it happens, is negative 54. Which means that the equation of our tangent line here works out to be just y equals 135 over 4x minus 54. Okay, so that is derivative review number 4, or sorry, derivative review 4, number 2. Okay. Again, if you have any questions about any of this, please feel free to email me, post on the forum, stop by office hours, post a YouTube comment, whatever. I'll get any of those and can respond within a day or two at most.